हेलो दोस्तों, कैसे हो। मेरे इस YouTube चैनल में आपका स्वागत है। तो चलिए शुरू करते हैं। डिजाइन ऑफ वेल्डेड जॉइंट। Now, welded joint means weld. Now, what we weld, we generally weld suppose two plates. So this is one plate like this, and there is another plate like this. So for example, I will place it somewhere here. Another plate. Okay, and I want to weld these two plates. Or the plate can also be like this, the bottom one, and I want to weld the black color plate and the red color plate. Okay, so how will the welding happen? The welding will happen like this. So I will keep this black color plate here. I am not going to explain what is welding and how welding is done. I am going to talk about the design aspect of that welded joint. On the top it is red color, black color plate, and on the bottom it is red color plate. Okay, and then welding will be applied. You can apply welding here, here. You can also apply welding here and here. Okay, so there are four places where welding can be applied. Obviously below the black color plate and above the red color plate welding can be applied. Okay, depending on where the welding is applied, it can be called as transverse weld or parallel weld. Before no, I'm going to show this in the form sketch. I have a model with me, but wait for that. Before that, when we weld, we call it as a fillet weld. Fillet weld, what is fillet weld? Fillet weld is, suppose this is one plate which is to be welded to another plate here. This is front view, and in order to draw top view will be something like this. Top view will be like this. Suppose these are the two plates. Okay, and we are applying fillet weld. Okay. So where the welding will be done? Welding will be done here. Okay, here means here welding will be done. Similarly from the bottom. Now this weld which is done, which you can see in the form of a triangle. Okay, this is called as fillet weld. Fillet weld. Sometimes you can see the sketch like this also. A reinforcement is provided. So instead of triangle, it is circular like this. You can see two plates. This is the bottom plate. This one is the bottom plate, and this one is the top plate. Okay. I should have colored it by different color, but right now it's not colored. So you have to adjust with this. So you can see this is the bottom plate. This is the bottom plate, and this one is the top plate. This one is the top plate. Okay. So these two plates are connected. These two plates are connected. How they are connected? You can see they have been joined here. The plates are joined here. So where it's the weld, you can see this green color. This green color is the weld. Okay. This green color. This is the weld. Okay, so it's welded at two places. So this is throughout. You can see this entire green color is the weld. I hope it is visible to you clearly.
Yes, sir.
Okay. So this is from the top. Now I will show the bottom of the plate like this. So this green color is the weld. Okay, this is one form of weld. Otherwise, the welding can be done here also. Here. So these are the two plates. You can see they are welded, and you can see it has become a single plate. You can see a force is applied here. Can you see the arrow? the force is applied here. Okay, and similar arrow goes here. So the upper plate is pulled in one direction and the lower plate is pulled in one direction. So this is what I was showing to you. This is the weld and this is the weld here at the bottom. Okay, this is the weld here at the bottom, this blue color triangle, this one, and similarly this triangle. So this is fillet weld. So one, and in this view you can see it is welded here, and this we will see from the bottom or by reversing the plate. This is on the bottom side and this is on the top side. Okay. Depending on how the weld is applied, we can, these are all fillet weld. First, second and third, three sketches are there in front of you, and all these three sketches are fillet weld. Okay. The first one is showing a single transverse fillet weld. Now for time being you forgot about this arrows which is indicating the load. इसको भूल जाओ. ठीक है. Consider this plate. So you can see this is one plate and this is another plate. Okay, so you can see this first, second and third sketch. This is one plate, this one. I will shade it with this color now. This one is the first plate. Okay, and this one. And this is the second plate. Let me use another color, second plate. This is the second plate. This is the second plate. Okay. So we can see these two plates are connected. These two plates are connected, or rather the correct word here is joined by means of welding. You can see the welding here. Okay. And this is the second case, double transverse, where you can see welding at the bottom and welding at the top. Now this is similar to this and similar to what I had shown to you by the with the help of model. So here the welding is done here at the bottom as well as top of the plate. This is called as, the first one is called as single transverse fillet weld. These are fillet weld. Second one is called as double transverse fillet weld. डबल ट्रांसवर्स मतलब दोनों साइड से किया है वेल्ड, ऊपर से और नीचे से, दोनों साइड से. यहाँ पे एक ही साइड से वेल्ड किया है, दिस साइड इज नॉट वेल्डेड, सो इट इज सिंगल ट्रांसवर्स. Okay, so you keep in mind this word transverse. Okay, I will talk on this word transverse afterwards. Now this is the third sketch, parallel fillet weld. Parallel fillet weld में weld कहाँ पे किया है? So this is, now you have understood this. You have understood this B case. Okay, B case. Now in the B case, instead of applying the weld, as you can see here, the black color, instead of applying the weld here, if I apply the weld here, okay, can you see this? I am using the green color to show the weld. If I apply the weld here, then what happens? It becomes parallel fillet weld. It becomes parallel fillet weld. Matlab, this is the bottom plate. This one is the top plate, and top and bottom plate are welded. But instead of applying the weld here or here, that is at 1 and at 2, which I had shown you in the model, instead of applying it here, it is applied here. Say at 3 and at 4, either 3 or 4 or both 4. So if it is applied only at 3, then it is called a single parallel fillet weld. Single parallel fillet weld. And if it is applied at both 3 and 4, then it is called as double parallel fillet weld. Double parallel fillet weld. So this one is representing double parallel fillet weld. So instead of applying weld here, that is here, instead of applying it here, it is applied here. So this is how it will be represented in the sketch. I hope this is clear to all of you. What is single parallel, double parallel, and what is single transverse, double transverse. Now, we have seen 4 cases: single transverse, double transverse, single parallel, double parallel. Now why here, see, why is it called as parallel fillet weld? Fillet weld because the weld is like this. The shape is of fillet weld. Okay, so that's why it is fillet. So all these are fillet weld. Now parallel means you can see these two plate. So plate A and plate B, and the load applied to this plate A and B and the weld are parallel to each other. That's why it is called as parallel fillet weld. The load applied and the weld is parallel to each other. That's why it is called as parallel fillet weld. Whereas in this case, you can see here C and D, the load applied is perpendicular to the weld, or the weld is such that the load is perpendicular to it. In both cases, C and D. That's why it is called as transverse fillet weld. Okay, transverse fillet weld. Now this explains single transverse, double transverse, single parallel, double parallel. I hope the things are clear to all of you. Now when I pull this force here and this force here, both this force, when this force is applied, what will happen? This weld here and this weld here, both the weld will come off. तो टूटना क्या है इसमें? प्लेट्स नहीं टूटेगा. ओके, देयर कैन बी फेलियर ऑफ प्लेट आल्सो, बट वी आर नॉट स्टडिंग द फेलियर ऑफ प्लेट इन दिस केस. ओके, ये प्लेट भी टूट सकता है खींचने की वजह से, ये भी प्लेट टूट सकता है, टेंशन में टूटेगा खींचने की वजह से, बट वी आर नॉट इंटरेस्टेड राइट नाउ इन द फेलियर ऑफ प्लेट. वी आर इंटरेस्टेड इन द फेलियर ऑफ दिस वेल्ड as well as this weld. Okay, this weld and this weld, so we are studying the failure of weld. इसका मतलब ये नहीं है कि प्लेट नहीं टूट सकता है. प्लेट का डिजाइन हम नहीं कर रहे हैं, हमने सपोज प्लेट का डिजाइन कर दिया है. ओके, दिस इज करेक्ट, प्लेट डिजाइन इज करेक्ट. नाउ वी आर डिजाइनिंग दिस वेल्ड. ओके, सो फॉरगेट दैट प्लेट विल फेल इन टेंशन. इसको बाजू में रखो, ये हम पढ़ चुके हैं. अभी हमको क्या पढ़ना है? ये वेल्ड का टूटना पढ़ना है हमको. सो डिजाइन ऑफ वेल्ड इज व्हाट वी आर गोइंग टू स्टडी नाउ. So this weld and this weld, when it is pulled, it will fail in what? It will fail in tension. The force applied is such, because it is transverse, इसको perpendicular है. Perpendicular है तो ये कैसे टूटेगा? टेंशन में टूटेगा. Okay. Instead see, this is one plate, this one is one plate, this is another plate. Okay, and if I apply weld here, suppose ये पीछे का प्लेट और बड़ा था, ऊपर बड़ा है. ये unfortunately I don't have that model right now. ये पीछे का जो प्लेट है, this one is bigger than this, then the weld applied will be here as well as here. So when the weld applied is here as well as here, then it is double parallel. If it is applied only here or only here, it will be single parallel. Okay, now we'll understand how this failure happens here. Now this is triangle, this you can say is triangle. Can you see the triangle, all of you? बट एक्चुअल में ये ट्रायंगल नहीं बनेगा. इट मे नॉट बी ट्रायंगल, इट विल बी स्लाइटली कर्व ऑन दिस सरफेस. ये कर्व आएगा. ओके, सी इट विल बी लाइक दिस. ओके, एंड सी ये कहाँ से दिखेगा? ये ट्रायंगल कहाँ से दिखेगा? इफ आई सी दिस फ्रॉम हियर, आई हैव टू सी दिस फ्रॉम हियर, देन आई कैन सी द ट्रायंगल. ओके, ये देखो, यहाँ से देख रहे हैं ना, आई एम नाउ लुकिंग इनटू द बोर्ड. इसका ये टॉप व्यू है और ये फ्रंट व्यू है. सो फ्रॉम वेयर आई विल सी द ट्रायंगल? फ्रॉम हियर. ओके, दिस एरो इंडिकेट्स दैट यहाँ पे ट्रायंगल बनेगा. ये पूरा ट्रायंगल बना है विच कैन बी सीन फ्रॉम दिस व्यू एंड नॉट फ्रॉम दिस व्यू. दूसरे व्यू से नहीं दिखेगा. नो विल स्टडी दिस ट्रायंगल. ये ट्रायंगल जो बना है इसका स्टडी करते हैं. सो दिस इज द ट्रायंगल. तो यहाँ पर एक प्लेट है, देयर इज वन प्लेट हियर, देयर इज वन प्लेट हियर, and there is another plate here. This is one plate, this is another plate, and this is what? This is the thickness of the plate, T. This is also the thickness of the plate, T. And then this is provided, this has been provided some reinforcement. मतलब एक्स्ट्रा यहाँ पे हमने थोड़ा वेल्ड में मटेरियल ऐड कर दिया. व्हाई? जस्ट टू इंक्रीज द स्ट्रेंथ ऑफ द वेल्ड, टू इंक्रीज द स्ट्रेंथ ऑफ द वेल्ड, वी आर एडिंग सम एक्स्ट्रा मटेरियल. नाउ वी आर इंटरेस्टेड इन ट्रायंगल. नाउ इफ आई कंसिडर दिस ट्रायंगल फ्रॉम दिस पॉइंट टू दिस पॉइंट, this point to this point, this is a perpendicular line. So this line which I have drawn, AB is the minimum distance line. AB is the minimum distance. Okay, minimum distance. So it is called as throat. It is called as throat. Failure will always occur at what? At minimum area. failure will always occur at minimum area. So this is the minimum distance. So if I want to talk about area, इसका area कैसे होगा? See, this is now 2D. This is now 2D. What I will do is I will make this 3D. इसको मैं 3D यहीं पे बनाता हूँ. And if I make this 3D, how it will be? ये प्लेट ऐसा है, ठीक है, ये प्लेट है, एक बॉटम में भी एक प्लेट है ऐसा, ये बॉटम का प्लेट है, और यहाँ पर वेल्ड है, ये पूरा वेल्ड है, ये कौन सा है, ये वेल्ड है पूरा, करेक्ट. सो दिस इज द मिनिमम डिस्टेंस ए बी. ये डिस्टेंस हो गया, इसका एरिया क्या आएगा? दिस इंटू दिस, ये पूरा एरिया हो जाएगा. सो इट विल बी मिनिमम area. Might be feeling some theoretical concept. It is minimum area. तो मिनिमम एरिया क्या हो गया? लेट मी कॉल दिस एज ए बी. ए बी तो एक डायमेंशन है, एरिया मतलब दूसरा डायमेंशन है. दूसरा डायमेंशन मतलब इस डायरेक्शन में डायमेंशन कौन सा है? लेंथ. देखो कौन सा है, ये डायमेंशन कौन सा है? एल. यहाँ पे देखो, दिस इज व्हाट, दिस इज एल. और थ्रोट कौन सा है? ये, दिस इज ए बी. दो व्यू लेके ही हमको एरिया मिलेगा ना. वी विल हैव टू टेक टू व्यू. सो ए बी इज दिस डिस्टेंस, ये जो यहाँ पे नहीं दिख सकता है, इनटू एल. दिस इज द मिनिमम एरिया एंड फेलियर विल occur along this area ए बी into एल. Now instead of ए बी, what I will say is ए बी is throat thickness. Throat thickness denoted by T. So what is minimum area? Minimum area is equal to T into L. इस T into L मतलब यहाँ पर ये कैसे आएगा? ये AB ऐसा है और ये क्या है? This is what AB. ये पूरा थ्रोट में, ये क्या है? L. Okay, same AB I have drawn here. So this area is the minimum area of weld. Minimum area of weld. और failure कहाँ पे होगा? Failure will happen or at minimum area only. So that's why we have taken or considered this area. ठीक है. I think you have understood this minimum area क्या होता है, कैसे मिला हमको. अभी हम इसके लिए थोड़ा मैथमेटिकल इक्वेशन फाइंड करते हैं, क्योंकि we don't know this T. ओके, ये AB जो है, इसको 1 minute. ये यहाँ पे जो T लिखा है ना, it might be confusing for you. Let me change this notation. Thickness of plate को हम लेते हैं S. S is thickness of plate. What is S? S is thickness of plate. Thickness of plate. और T is what? T equal to throat thickness. मतलब उसी प्लेट का थिकनेस, उसी वेल्ड का थिकनेस, लेकिन कहां पर? थ्रोट पर. we will see how to find a relation. So in order to find relation, what I say here is stress is equal to load upon area, or load equal to area into stress. Load equal to area into stress. So what is the load applied here? Load applied is P. P. What is the area? Area is T into L. And what is the stress? Stress is sigma T. If we are talking about fillet, transverse fillet weld. Transverse fillet weld. Then the stress will be sigma T. Now we have to find some relation here of T. So you can see this triangle AB and C. AB and C. What I will do is I will take that triangle here and draw it again. It is like this. We have denoted this point as B and we have drawn a perpendicular here. Why perpendicular? Because minimum distance is obtained along the perpendicular distance, perpendicular only. What is this? S. What is this? S. Both are equal. And what is this? T. Okay. Now since this is S, this is S, so this will be what? This angle will be, this is 90. So this will be what? 45 degree. 45 degree. So if I write here sine 45, so sine 45 will be what? Opposite. That is AB upon hypotenuse. Hypotenuse is what? S. So I can write here what is the value of sine 40. I can write here AB equal to S sine 45. What is AB here? AB is throat thickness T. Sine 45 is 0.707 into S. So instead of T, what I can write? I can write T equal to 0.707 S. So here I can get P is equal to 0.707 L S sigma T. So this is one equation to find any of the dimension whichever is unknown. What is the equation? P equal to 0.707 Ls into sigma T. This is for single transverse fillet weld. And what is this P? P is the load applied. So if I want to find it for double transverse fillet weld, what I will do? P equal to multiplied by 2 because it will be from both the sides. So 1.414 Ls into sigma T. Ls into sigma T. This is double transverse. Double transverse. So what is the equation for single transverse? P is equal to 0.707 SL into sigma T. For double transverse, it will be P equal to 1.414 Ls into sigma T. Similarly, if it is parallel fillet weld, then what will be the equation? If it is parallel fillet weld, then the equation will be P equal to 0.707 Ls into tau for single parallel fillet weld and P equal to 1.414 Ls into tau for double parallel fillet weld. Double parallel fillet weld. Okay, so we have these four formulas. Okay, so question based on this can be asked in your class test as well as in gate examination. Simply, instead of sigma t, they will give something. They will not give sigma t, they will give principal stresses. So principal stress sigma 1, sigma 2, sigma 3 is given, out of which you will have to find what is the value of sigma t. Or sigma 1, sigma 2, sigma 3 will be given, you will have to find the value of tau. So you have studied this in strength of material. Also, I have explained this to you while I explained the theories of failure, how to find the value of sigma t or tau from the principal stresses, maximum and minimum principal stresses. Weld, this is what? This one. You can see this is, if the weld applied is here, see in the sketch, here and here, then it becomes what? Double parallel. Double parallel. And instead if the weld applied is say here and here, green color, then it becomes double transverse. Okay, and load applied will always be like this. Load applied will always be like this. And now you must be thinking why it is double parallel or single double transverse. Can it be combination of double parallel and single transverse or single or double transverse single parallel? Yes, it can be combination of that as well. Then in that case, what will be the formula? The formula will depend on which of this you are taking. If you are taking this, okay, if you are taking this two and this, then what will be the formula? 1.414 Ls into tau plus 0.707 Ls into sigma t. Okay, that we will have to use the combination of formula.